Hi, let us look at a few review questions together. So first, number 21. Which of the following is the value, as you can see, expressed here? Now, so then what we're going to be doing is we're just going to set up the table. What if I values are 2 through 5? And what we have to do is put those values in place of I. Now, then once you calculate that, first value is equal to 1, and second value is equal to 6, and 13, and 22 as well. So when you combine them together, we end up getting 42, hence choice 1, 42 becomes our answer. All right, let's move on to the second question. The sum of the first 100 positive even integers. So then essentially what we're looking at is 2 plus 4 plus 6 all the way up to certain numbers. But when they say first 100 positive even integers, then we realize that each term will be first defined by the first term, which is 2 plus m minus 1 times d becomes 2 because that's the common difference. And since the last number here would have been equal to a sub 100, so when you plug in 100 in place of n, you're gonna get this expression, and your final answer becomes 200. Now 200 is not the answer at this point because we're looking for the sum. So sum is 2 through 200 as you increase the even integers. So sum is equal to n times, which is number of terms, times the first number plus the last number. Divide that by 2. Then what we end up getting is we have 100 terms. And first number is 2, last number is 200, and divide whole thing by 2. Then we end up getting 10,100. That becomes our final answer. All right, let's move on to the next question. So what is the value of the arithmetic series similar to the previous question? First term is negative 100. Common difference is 8. And then it has 30 terms. So that means first what I need to do is I need to figure out the last term, which is, we know the a sub 1 is negative 100. And we know the formula a sub n has to be equal to negative 100 first term plus m minus 1 times the common difference, which is equal to 8. Now then what we're looking for is a sub 30. So when we plug in 30 in place of n, we'll get this expression. And then what we end up getting is 132 is the last term value. Then how do you find the sum? Sum is once again number of terms times first plus the last, divide that by 2. So once you calculate that, first term times the what? 16, we got 16 because 32 from here divided by 2 becomes 16. And once you calculate them, we get 480, which is choice 4. All right, let's move on to the next problem. Number 24, we want to find out the geometric series as shown over here. So sum of the geometric series is the first term times 1 minus r to the n power over 1 minus r. That's one formula. Or actually another formula for that would have been this one. First term minus the term after the last term. You see here, a sub n plus 1 is a term after the last term. And then divide by 1 minus r. We can do either way. Since we get next term by multiplying by 3, r is equal to 3 here. So the last term after the last term would be 98,415 is multiplied by 3. Then we get 295,245. So using that number, we should be able to complete our sum. Over 1 minus 3. Then what we end up getting is this value. We got it from calculator. Therefore, choice 2 becomes the answer. All right, let's move on. Number 25. So they want us to find the fourth term in this sequence. So this is a recursive formula. So that means a sub 2 must be based upon the formula is equal to a sub 2 minus 1, as you can see right over here. That means 1 before the term that which we are looking at, so which is a sub 1 times 2 to the n. N has to match the placement of the term, which is 2. Then this is what we end up getting. We get 28. That's the second term, but we want to go to the fourth term. So that means we need to continue from a sub 3, which is equal to a sub 2 times 2 to the 3 power, which is 28 from the previous result. Multiply that by 8. We get 224. Now finally, a sub 4 becomes the third term value times 2 to the 4th power. Then we get 224 times 16. Hence we end up getting 3584 becomes our final answer. All right, let's move on to the next problem. So a line segment is broken into forms a geometric sequence. Smallest one is 16, so that means a sub 1 is equal to 16. And 5 of them, so last term, longest one is a sub 5, which is equal to 81. How do you find r? R can be found by using the formula a sub 5 must be equal to a sub 1 times r to the 4th power. So a sub 5 is equal to 81, and a sub 1 is equal to 16. So simply dividing 16 from both sides, we get r to the 4th power should be equal to 81 over 16. That means r should be equal to 3 over 2. Now, second one is what is overall length of the line segment. Then in this case, we're looking at sum. So as you know, sum is equal to a sub 1, first term, times 1 minus r to the n power over 1 minus r. So we're going to plug into the formula here. First number is a 16. Since r equals 3 over 2, and then n equals 5 because we have 5 pieces, and that's what we end up getting. When you put that into a calculator, you get 211. That becomes our final answer. All right, let's move on to the next problem. Number 27. So here we have, when you read it, each bucket has only 80% of the previous amount. So that means here r is equal to 0.8. And we are looking for total. That means we are looking for the sum has to be greater than 200. So I'm going to write up the formula first of the sum, just like the previous case. And what if we set the equation equal to 200? As you can see over here, a sub 1 was 50 because that was the first bucket, equals, and r equals 0.8, so that's how we completed the equation. Now, 1 minus 0.8 becomes 0.2, so I just group 50 and 0.2 together, right over here. Then what we end up getting is this expression. So now 200 is equal to 50 over 0.2 is in fact 250, and then copying the rest of them down from the previous equation. Now 250 is being distributed, then that's what we end up getting. So when we subtract 250 from both sides, we get negative 50, which is equal to negative 250 times 0.8 to the nth power. So when I divide both sides by 250, then we get 0.2. So 0.2 equals 0.8 to the nth power. So in other words, n will be equal to, since n is in the exponent, we have to use a logarithm to get our answer here. Then n will be about 7.2-ish. But if we have 7, then we're going to become short. So therefore, we got to have 8 times. We need to put the water 8 times. That becomes our final answer. All right, let's move on to the next problem. So angle drawn in the standard position is 10 radians, and then we want to see which quadrant it lies. So we know that angle around the circle, angle around the point will be equal to 2 pi. So obviously 2 pi is about 6.28. So 10 is more than that. So what I have done is I subtracted 10 minus 2 pi to see what that might be equal to. It's about 3.72. So that means when you look at the quadrants in radian measures, between 0 and then pi over 2 is the first quadrant. Next one is pi. Next one is 3 pi over 2. But let's try to convert this one into decimals so that we can compare that with 3.72. So the first one is 1.57. So pi over 2 is about 1.57. Pi, as we know, is 3.14. 3 pi over 2 is about 4.71. So that means our answer, which is 3.72 over here, should be between, it should be right over here. So in other words, that would be third quadrant, would be our answer. Now, let's look at the last question here. Since AB diameter is 30, we know the radius is 15. And then the length of the arc from A to C is equal to 40. Then we want to find out the measure of the angle. How do you find the measure of the angle? Angle is length of the arc divided by the radius. This is in fact the definition of the radian measures. So all we have to do is 40 divided by 15, which is equal to 8 over 3. That's it. I'll see you later.